Hey everyone, I'm back with an update. So we being me and everybody else on my university's student-run space program, Student Space Technology Association of University of Tennessee, Knoxville. I just wanted to give you an update of what we've been doing. So we've been our first project is a high-altitude balloon that's going to be going up to 30 kilometers, and so I am in charge of electronics, as most of the other people on the team are aerospace engineers. So I've been in charge of electronics and wanted to demonstrate our latest accomplishment, which involves our comm system. So our flight controller is going to be a Raspberry Pi 2. It's going to be running all the experiments, all the cameras, and bringing down GPS telemetry, as well as controlling the descent and ascent procedures for example, the parachute and whatnot. So the comms system that we've chosen is rather simplistic, if not costly. We've chosen to use these Digi International RF modems. This is the, if I can pull it up, the Digi Extend 900 1 watt RF modem. They're $200 a piece, so they're pretty costly, but considering our altitude is going to be going up to 30 kilometers in the air, we need the range. And that's actually with a high gain dish antenna. Right now we're just going to be using these dipoles, or the dipole on the balloon itself, and then potentially put a directable dish antenna on our chase car while it's in flight. So how these guys interface, by default they're just transparent UART, so basically they just act as a wireless serial cable. And so right now I've got this one hooked up to just a Arduino lying around that we're using as a dummy terminal, and we're just piping serial through it. And on the other end, nice handy feature about the Raspberry Pi that we chose over, say, a BeagleBone or other equivalent single board computer, excuse me, is that, if I can demonstrate. So there's our Raspberry Pi flight controller right up here. The ribbon cable is a camera, and there's the other RF modem, and I'll demonstrate the power board and miscellaneous board in just a moment. The nice thing about the Raspberry Pi, as I mentioned, is that it has a dedicated UART port for shelling into. So instead of doing wireless or connecting via, say, just camera and whatnot, or video and keyboard and whatnot, we can just shell in via serial. So I'm going to go ahead and just connect. Yep, we want serial, we want that right now. So right now it's already booted up, but I'm going to reboot it in a second. So I'm going to log in with normal credentials, Pi, Raspberry, and ask for the password, so put in Raspberry. There we go. There's all the login information. So I'm going to do a sudo reboot. It's rebooting. Give it a second. There's the reboot sequence. Starting now. So you can see from the RX and TX, or just the transmission LED, is that we're receiving all the data via the RF modem on the Pi, and that's interfaced via a 3.3 to 5 volt UART, because these RF modems operate on 5 volts, and the Raspberry Pi's UART is 3.3 volts. So there's the login information. Let's log in again. Pi, Raspberry, just SA or LS. So we have some of our code, but that's on the other home directories. I'm just logging into the main one that we're going to be collaborating all of our code and modules for. For example, we're using a few humidity temperature sensors. We're using the SenseHat, which is a sensor suite that pops right on top of the Pi. That's got a magnetometer, accelerometer, gyro, humidity, and temperature. We're putting a spectrometer, which is just a webcam with a spectrometer filter over it, so that way we can take atmospheric data, as well as the Raspberry Pi camera that's done dedicated. So that's the gist of it for now. I'll get some pictures and demonstrate the